everyone, welcome back to the Introduction to Data Science using Python series with Shambhavi. Today we're diving into a cornerstone of predictive modeling, that is regression modeling in Python. In this video we'll cover an introduction to regression modeling, how to evaluate regression models and stepwise regression to optimize your model. We'll explore the theory, write Python code for real world examples, and interpret the outputs step by step. So, grab your coffee and let's dive right in. Let's start with the basics. What is regression modeling? Regression modeling is a type of supervised learning that predicts a dependent variable or target based on one or more independent variables that are predictors. There are two main types of regression. Simple learned regression, it is used when there is one independent variable. Multiple linear regression, it is used when there are multiple predictors. Now that we understand regression modeling, let's move on to evaluating the model. The accuracy of a regression model is typically evaluated using metrics like mean absolute error, mean squared error, and R squared. Mean absolute error is the average of absolute differences between predicted and actual values. Mean squared error is the average of squared differences, while R squared is the proportion of variance in the target explained by the predictors. The applications of regression modeling include forecasting and prediction, identifying relationships between the variables, and medical research, economics, and more. Now, let's calculate these metrics for a simple linear regression model using Python. Here's the code for the estimation model evaluation, and here's what the output of this code tells us. Mean absolute error. This gives the average magnitude of prediction errors. For example, if the MAE is around 0.53, it means the model's predictions are off by about $53,000 on average, since the target is scaled in the units of $100,000. Mean squared error. Mean squared error penalizes larger errors more heavily. A smaller MSE value indicates better performance. R squared. This value indicates how well the model explains the variability in the target variable. For example, an R square of 0.61 means the model explains 61% of the variation in house prices. Finally, let's optimize the regression model using stepwise regression. Stepwise regression automates the selection of significant predictors. It adds or removes variables iteratively based on their contribution to the model. This technique can avoid overfitting by reducing the number of predictors and improve the interpretability of the model. Here's how to implement stepwise regression in Python using forward selection. In this code, we use stats models to perform linear regression iteratively for each combination of features. At each step, the feature with the highest adjusted R squared is added to the model. The process stops when no feature significantly improves the model. The output lists the selected features which are the most relevant predictors for our target value. And here is the output for the stepwise regression. Selected features. Selected features for the Boston housing data set like RM and LSTAT might be selected. These are the most significant predictors of house prices. This process eliminates irrelevant or redundant predictors, resulting in a simpler and more effective model. And that's a wrap. Today, we explored the fundamentals of regression modeling, evaluated a linear regression model using Python, and optimized it with stepwise regression. If you enjoyed the video, please give it a thumbs up and subscribe to Shambhavi Manjrekar for more tutorials. Let me know in the comment section which machine learning topic you'd like me to cover next. Thanks for watching and I'll see you in the next one.